So I know that I'm currently the only thing standing between you and the break. It's a painful position to be in, so please bear with me. This is going to be fast and hopefully painless, at least for you. So I'd like to start this section providing an overview of all of the tools that our wonderful colleagues have presented. The idea here is that, if you need to take something home, it would be this slide over here. This is a summary of both the local and the tools that can be run on the cloud. Let's start with the local tools. We have a big block of tools that belong to the Qiskit SDK. Here we have our beloved preset pass manager. Just as a reminder, whenever we have talked about Qiskit transpiler performance, Qiskit transpiler runtime, etc., what we are actually thinking is about this preset pass manager. So this is what all of our results relate to. Apart from this pre-configured or curated list of passes, we also have an extensive pass library that we can use to build our own custom pass managers without actually developing the passes. And we also have a library or a collection of built-in transpiler plugins. Matthew already talked about them. We have the high-level synthesis one, unitary synthesis ones, probably forgetting some. There are a lot. On the same fashion, we also accept, because of this pluggability of the interface, external transpiler plugins that can be exposed as pip installable packages in repositories in the Qiskit ecosystem. Now, for the cloud tools, as you have also seen, they are not exclusively cloud tools. They can also be run locally, but it's a differentiating factor, so I put them in a different box. We have the passes that can be run in Qiskit runtime, as Peter just presented, error mitigation and, or dynamical decoupling and twirling. And we also have the Qiskit transpiler service with the routing and the synthesis passes. So this is how you install them. They all belong to different packages. The purple ones are the ones that are managed by us, and the red ones would be external plugins that anyone could contribute to, especially you, now that you're here and you're experts in the transpiler after an hour and a half. I would also like to present this little guide or pseudo guide of what to use when. So it's actually difficult to give a simple answer of when should we use each tool, but this is why we have it in this format. So we start with this matrix. The first two rows correspond to both users that are maybe not so familiar with specific details of how passes work, or maybe they know about them, they just don't want to spend the time configuring them. So if you want a pre-tuned pipeline, something with a low entry barrier, and that you know that will work decently well, then we recommend pointing to the preset pass manager as well as the runtime passes that you can easily just turn on and off with some runtime options in the primitives, as well as the transpiler service. Now let's say you want to go a bit deeper. You want to tweak things here and there. Then you can take advantage of the pluggability Matthew talked about, and you can either start off from a preset pass manager, you can just build your custom pass manager, or you can take advantage of the external plugin. So there's a lot of room for playing around there. If you want to, just have the thing that works the best for your application, then you might just end up developing your own full custom pass manager with potentially custom passes. This requires a relatively long development time, but can lead to great results if you know what you're doing. Finally, again, a reminder, when we're talking about the Qiskit speed, Qiskit transpiler speed, we're, let's say, tying that guarantee to the preset pass manager. However, this doesn't mean that the other tools will not potentially be fast. It's just they are not the ones that have been benchmarked. Now, you might notice that I'm missing a pretty important row here, which is what about the quality, right? What is best? Again, I am avoiding this on purpose. This is a tricky question to answer. But instead, I'm going to offer you a list of questions instead of an answer. So the idea here is that you will probably have to iterate a little bit and go through some trial and error. So we have pre-configured for you the preset pass manager. This is also accessible through a Qiskit transpiler service, so that's a pretty handy option. And we recommend just starting from there. It's pretty fast, and it will lead to really good results in most cases. Once you run that, you will have an idea of what your circuit depth is, what is the number of gates. You can contrast that with the device you're going to run it in. You can maybe see whether there are some limits that you're exceeding that you wouldn't like to. And then is when you start developing, okay, what are my target metrics? What do I want to optimize for? Is the qubit count? Is it the depth? Probably a mix of both. Do I just care about the transpiler being very fast because whatever is in my pipeline? So I think it's important to just pick what is our favorite or most important metric, because of course there are always trade-offs and you cannot just optimize for everything all the time. We try, but it's not perfect. Now, some other considerations that tie together with the content of everyone else are if you can connect your problem to some of the AI passes that have been presented, then boom, just try an AI transpilation pass. If you think there's some plugin that can also connect to your use case, then just go ahead and try it. I think Julian yesterday talked about the Rustic plugin. This is something we're pretty excited about now. And it's already exposed as a built-in plugin in the Qiskit transpiler or preset pass manager. Ali will show an example later in the second session. So, it's something that might be worth a try. And then it's always important to analyze both our circuit and our target. So if we start from the target, some questions. This is non-exhaustive. I might be forgetting something, but it's probably interesting to look at the symmetry, just see whether there's something in the structure of the coupling map that we can take advantage of. Yesterday, Julian talked about how we classify circuits depending on their structure or the high-level mathematical operations. This would be the structure part. So can we connect the structure of our circuit to the structure of the coupling map? Are the gates in our circuit matching the ISA set or the support instructions of the target? So these are just things that we should pay attention to. As for the circuit, this would be the second type of operations we can use. So are we using these higher level gates from the circuit library? Something like the polyevolution gate. In this case, we will likely need synthesis. If this is complicated, then we can try the new AI passes. We can try the new plugins. As for routing, there are some known solutions for certain routing problems. One example is the QAOA ansatz. This is something that you will get a chance to try in the challenge later, so I'm not going to spoil it too much. But there are passes that are not part of the preset that you can manually configure and will lead you to an optimal routing in this case. So something that is good to think about. Finally, if you end up building a custom pass and you want to expose it, we welcome plugins. Well, the ecosystem welcomes plugins. So it's always something that you should also think of. And this is it. It's pretty simple. I said my part would be quite fast. I do have a few code examples, just as a refresher of everything we've been through today, this journey. So we start with the preset pass manager, our dear friend. We imported from Qiskit, Qiskit.transpiler. If we don't set an optimization level, as Matthew repeated 18 times, the default will be optimization level 2. However, if we want something different, then we can set it manually, for example, to optimization level 3. Every time we have a pass manager, we call it through passmanager.run. So this is let's say, the pattern we will see. Let's see a custom pass manager. So here, we import the pass manager class from Qiskit.transpiler, and then we can import the individual passes from the pass library. And then we just concatenate them in a list, and we give them to the pass manager. Once we have it, we can call it with passmanager.run. But this is not the only way of having custom pass managers. We can also plug them into one of the stages of the preset. Do you remember there were 6 stages? Let's say we want a custom init. This is actually not custom. I copied one init. But let's say we want to do that. Then we can generate the preset with the snippet I showed at the beginning. And we can just create our own custom pass manager and plug it. You see it there, custom pm.init. And that's it. And then we just run it, same as before. What if we want to use the famous built-in plugins? Just in case you didn't catch it. these built-in plugins that we expose in Qiskit, they can be configured through their own config classes. So this is for the high-level synthesis plugins. There's this class called HLSconfig, and there you can set a lot of options. I should have added a documentation link here, but I recommend you to look up high-level synthesis plugins. That should probably show up. And it will give you a description of what these weird words mean, like PMH, what is this? It's homework. Now, once you have this config, you can give it through the HLSconfig option in the pass manager generation. And then it's already baked into the pipeline, so you just have to run it. The last local tool that I'm showing is, again, a refresher of how to run AI passes, and I'm also showing a slight different pattern than before. This is true for all the previous passes. So you see that here we're importing an AI routing pass from the Qiskit IBM transpiler repo. We are defining a backend from Qiskit IBM runtime, and then we define the pass, similarly to what we did before, and we're running the pass directly. There is no pass manager. This can also be done for most passes. You just call them without the run, and they will run. The run is associated to the pass manager, so just a small thing I wanted to clarify. As for the cloud tools, the snippets are much shorter because things are managed for you. In this case, we have an example of running the transpiler service with AI true. This would run a collection of AI passes in a mysterious way that I'm not super familiar with, but it will be amazing. We also have the runtime dynamical decoupling as an example. It should be equivalent for twirling. This is just, again, a refresher. You can import the estimator, and then you can set, or you can enable these error suppression techniques through the estimator options. And then you just run the estimator, and things will be done. So I think that is it for me. As I said, it would be short and sweet. I will leave you with the tool overview and maybe hand it over to Abby.